So in this Jupyter Lab, we see the code for graph. So last time we already looked at the details about the code. So we are using the X list. Okay. So the X list means this is one of the data structure for graph. And using this X list, we want to add the graph here. So I show you the graph example. So this is the graph example. So we have the graph. This is the directed graph. There is an origin and destination. So we want to sorry. So we have the information that there's a route from Seoul to Daejeon, Daejeon to Busan, Busan to Daejeon, and so on. Okay. So you already have the code. Let me execute this one. So last time we already reached the section about the FS. Okay, so we have the figure here with the weighted, okay, and then because the weighted shows the information between the two nodes, so there is no direction. So that's why we put false here. And yeah, let's take a look on the depth first search. So we already learned from the video lecture the depth first search use this kind of mechanism. So in the PowerPoint, you saw this code, and then we want to construct the path. Okay? So we want to construct a path. We can define this construct path, okay? Or we can see only from the incoming or outgoing. So you can see from the construct path, and then let me run this. So you already have the concept about the DFS. So let's run the code. So here we want to use the DFS complete, and we are going to use the graph Korea. So the graph Korea is I think it is related with the yes, this one with the simple example. What is the simple example? The simple example is a function to create this graph. Okay. So this is the at list, and we have this at list into this variable graph Korea, and then we want to find the DFS. So the DFS will create a spanning tree. Okay. So the spanning tree, I think you already know from your quiz. Okay. So you already try to find the answer. What is the difference between the depth versus and breadth versus? So in the depth versus, we want to find the node, the child node, and then the child node, and then the child node until the last child node, and then we will go back to find the siblings. So this is the construction of the DFS, and we want to put it into this graph Korea. Okay, so we will use the DFS complete, and after we use this DFS complete, we want to check about the spanning tree. Okay, so the spanning tree is somehow random. Okay, so when you use the code, it will create any spanning tree. For example, here it starts from Daejeon. So it's from Daejeon, and then it says known. Okay, so here is the incoming. Okay, so we are going to find the incoming. Let's see if it is the incoming. So we have the here is Busan. So there is an incoming from Daejeon to Busan. So we can, how can I symbolize this one? Let's change this one. No. Okay, anyway. We have the Daejeon to Busan. Okay, so it is an incoming to Busan. And what about Suwon? So we have also another node, Suwon. There's an incoming. Okay, no, I cannot use this one. Maybe I need to use this. Okay, so there's incoming from Daejeon to Busan, and then there is incoming from Daejeon to Suwon, and then we have another incoming from Suwon to Seoul. Let me just type this one. Seoul. And then there is an incoming from Seoul to Gwangju. Okay, so that's the meaning by the result. Seoul to Gwangju. So it is the spanning tree from the DFS. Okay. So you can see that, okay, it's just a very strict line here. It starts from Daejeon. So sometimes it will change. Okay. See. Okay, now I think there is no changes, but sometimes the result can be changed according to the definition of the graph. Okay. Now, if I want to take a look on the graph one, so the graph one is related to the airport networks. Yeah, you can see like this one, and you can draw. Okay? You can draw this result. So the DFW, there is an arrow, or there is a directed edge from DFW to SFO. Let's say this one is SFO. Yeah. And then we have this is DFW. Okay, and so on. So we have the DFW to ORD. DFW to ORD. And you can create this kind of spanning tree. So we call it, this is a spanning tree because we want to check only the minimum connection between all the nodes. Yes. So maybe let me just finish it. The FW to the ORD, and then we have the ORD to MIA. MIA here, and then after MIA we have MIA to LAX. Okay, so for example, LAX is here, MIA to LAX. Okay. And then we have the JFK. Okay, so it's JFK, and it goes to Boston. JFK. And then we have another, which is Boston. So JFK, there is no incoming to JFK, but there is incoming to Boston, something like this. So we create a kind of forest. Okay. Yeah, in this case, yeah, there's a possibility to create a forest with the DFS. So we know that the limitation of the DFS One of them is it can create a forest. How about if we want to use the graph with the weight? So the graph 2 is the generated graph with the weight. Weight means this is the distance or the mileage between two airports. So if we want to check the items, then we can see that there is the incoming from San Francisco to Dallas. So this is the distance. There is incoming from San Francisco to LAX. This is the distance, and so on. So we can also create another tree for this one. Okay, so this is the result from the DFS. What about the BFS? The breadth first search. We also already learned about the concept, how the BFS run. So we need to create the level. Okay. So the level 0, and then we go to the next level, which is level 1, and then we go to the next level, level 2, until all the nodes in that level has been visited, then we will finish. Okay. So we have also the BFS complete, and we want to check whether all the nodes has been visited or not. And let's see, for example, this is from the graph Korea. Yeah, this is another incoming. So we have the Daejeon, and then we have Daejeon to Busan. Okay, like this one. We have this one is the Daejeon, and then we have Busan, and then we have Daejeon to Suwon. Yeah, I think the result is similar with the DFS because the node we have in the transportation system is very simple. So the result is quite similar with the DFS. Yeah, I guess, yeah, the result is similar with the DFS. So you already know how to get the graph or the spanning tree using the DFS. So this is the result using the DFS. And if you want to use the graph one, yeah, you can just input the graph one here, and then you can get this spanning tree. And then if you use the graph two, yeah, you can also do this one, and you can get the spanning tree. Okay. So that's about the DFS and BFS. So the assignment that you will do until next week is about BFS and DFS. So you need to find out how to get this code. Yeah, so you need to use this code and then try to adapt with the problem that I mentioned in the Gurum and solve it using Gurum. Okay, next is about the graph. Okay, maybe when you have your data set is too small, okay, and you are not able to run the experiment like what we did before the mid-exam. We try to create some random numbers. We want to create like 1 million data. Then you need to think how to make the graph randomly. So if your data is just a single element, then you can create numbers from the random function. But if it is related to graph, how will you do the graph randomly? So I'm giving you one tips how to create a graph randomly. So in this case, we will use one library called Network X. Okay, so the Network X is a library that has been embedded in the Anaconda, and you can use that one by calling the method. This is the method in Network X, GNM random graph. And we can create the graph with the number of nodes and the number of edges. So you can have 10 nodes, 30 edges. And then let's say you want to increase the number. I want to have n equals to 100 and m equals to 300. That's also possible. So you can get bigger graph. So in this case, I would like to make the G, this is a graph, and then I would like to make the n and m equals to 10,30. So after I have this information, I would like to put every of these ads into one file. We call it this the test.ads.list. So if you run this, you will see there is one file here. Okay, can you see? In the below part, you can see there is one new file created, which called as test@list. So this is the random graph generated by the network X. So if you open this, then it is a collection of edges. So we have the edge 0, 4, 0, 7, 0, 6, and so on. So it adds every edge into the graph. And then it is the way if you want to create a new file. But how if I want to append the edges into a list? So if you take a look on the problem that we have before, what is this data set? What is the data structure? If we use the square bracket, then it is a list. If we use the parenthesis bracket like this, then it is a tuple. Okay. If we use the curly bracket, it is a set. Or you can also use the curly bracket to indicate dictionary. Okay. So those four data structure are the embedding data structure in Python, and you can use it. Because the structure that we had here is using the tuple, you can change this random graph into tuple. How? So first, we can make a list. So you can create a list. This is an empty list. And then for every edges in this graph, let's append it into the list. So after we have this, then let's create a tuple. So we want to convert the list into a tuple. We have the LL tuple. So once we print, then we will see this is the collection of the graph. So if the graph, what we did before, it was related to the city name, Busan, Seoul, and etc. And this is a random graph. So we just use the numbers 0, 3. So it means there is a correlation between node 0 and node 3. 0, 2. So there is a relation between node 0 and node 2. And so on. So after we have this, then we can reuse the graph from the ads list. We will use the LL tuple, so we will use this information. And then we will put into one variable, which is graph random 0, 1. We already learned in chapter 3 about how to do the performance checking. So how we can calculate the runtime. So the runtime will be, we will use this time library, and then we need to define one function which is runtime, and then we call what is the function, and then what is the time. Okay. So this, sorry, I think this is the data. So we just start and then run the algorithm. After the algorithm finish, stop. So we will get the elapsed time, and then we will check what is the elapsed time. So if we apply into graph, in the first graph, in the first L, the LL tuple, we generate only 10 nodes and 30 edges. We want to increase 100 nodes and 300 edges. The same with the previous way, we want to create a list, and then after we have the list, we create tuple. And then we input this tuple into the graph with the edge list structure. Okay. And then after that, we want to run again with bigger nodes and bigger edges. We have 1000 and we have 3000. Okay. And then again, oh, yeah, if you want to finish with this one, yeah, if you want to do more, okay, so you can use more. I guess graph random tree. Yeah, I guess until graph random tree. Then we need to figure out how to get the time performance. So we use the from time, and then we define this runtime. This is the starting time. This is the ending time. So we want to use the DFS complete. So this is to check the DFS algorithm. And after we have this start and end time, we want to know the elapse, and it will return the elapsed time. So in this case, when you do with your team project, you need to have at least like 5 data set like this one. Yeah, if you have more data, then of course it is good. Okay. But if you can generate with 5, then it is enough to show the performance with the graph Korea, which is only 5 nodes, and then graph random 01, which is 10 nodes, graph random 03, which is 100 nodes, graph random 03, which is 1000 nodes, and then yeah, if you want to apply with the graph random 04, yeah, that's also possible. Okay. So let's just do with T1, T2, T3, and T4. Okay, so we don't have the random 04. Oh, okay, I have the 04 here. So let's make the other 04, because the time performance of the graph random 03 is too small. Maybe it is a little bit difficult to see the difference. So we can create another graph with 10,000 nodes and 30,000 nodes. After this, we have the runtime again. We have the T5. Okay, 0.04. Okay. So we have the T1, T2, T3, T4, and T5. Okay. We want to put it into a list. So this is the variable. We call it test DFS. So every graph, this is the graph, simple example. This is the graph random 01, graph random 02, graph random 03, and graph random 04. And we want to plot all the time into one list. And you will check later. We can do the same with the other algorithm. For example, we are going to check with the PFS. So here, this is the PFS algorithm, and then we want to check the time performance of the PFS. We just change. The first is using the TFS and the next is using the PFS. So you can run. So in this case, you can run the graph Korea in your graph random 01, random 02, random 03, random 04. And then we put into the variable S1. And then we again make the list of the time performance using the test DFS. So this is the S1, S2, S3, S4, and S5. In the later part, you need to show the graph. You need to show what about the performance. So the performance will be something like this one. X, it is related to the number of the data. So we have the graph symbol. The graph symbol contains only 5 nodes. And then next, the random 01 contains 10 nodes. The next one contains 100 nodes. And then the next one contains 1000 nodes. And the last one contains 10,000 nodes. So if we run this one, this is the information about the X. So this is the X axis. And let's see if we use the test DFS. Okay, the first data is very small, 0. The second data is also very small, 0. The third data, okay, is 0.0009. And then the fourth data, now the time is a little bit increasing. And then, yeah, this time is more than the previous one. So if you take a look on the big O notation, what is the big O? We know that the big O for the PFS and DFS is O n plus M. And we can check using the plot. So here is the library. I guess you can just use the basic library, which is the matplotlib. And you can use this matplotlib.py plot. And then you can use the pylab to show the label. So the pylab is to show the data and the X, what is the label, and then the label on Y. And then we can put the title, we can plot, and then we can show it. So we have this RO. The R means the type of the RO minus is the type of this line. So we can plot with the other algorithm. For example, in our case, we want to compare DFS and PFS. And using the same data, we just want to compare the time performance. Okay, now we have the X is data, again, the Y is time. Now we want to compare the DFS and PFS. So using the same type, okay, so we have the X for the test DFS. We use the line chart with the minus. Maybe you can change with this one if it is odd. Okay, this might be different. So you can take a look on the library. So there are some options, like if you use dash, then the figure or the line will be the same. But now I use dash and then I use the column. So there are difference. And then red is the color of the line. And then yeah, we have the blue, which is the second one. And then the legend is related to the DFS and PFS. So DFS is the first and PFS is the second. And we want to put it into the upper left. And finally, just show. So this is the result. Now we can analyze. Yeah. if you know that the big O is something n plus m, like this one. Okay, you can report that the big O notation for the algorithm is O n plus m. Now, based on time, we can see the time performance. When the number of the data increase, yeah, it is still not that high because with 10,000 data, we can get the solution in 0.04 seconds. Then it is still fast. You don't need to worry about the performance of your algorithm. So in this case, the PFS is slightly higher than DFS. Okay. So the first one, we can see the PFS is slightly higher. But at the end, okay, the red color, which is the DFS, is a little bit higher than PFS. So you can say something like that in your final presentation. And also, don't forget to mention about the specification of your computer, because different computer may give you different results. For example, if you use laptop, the result will be different if you use desktop. And if you use desktop, maybe the result will be different if you use the cloud. For example, if you use the Google Cloud. So you need to specify the environment, whether you're using laptop, whether you're using desktop, or whether you're using the cloud. Okay. I think that's all. I hope that it explained well what you should do in your final project, in your team project. So I hope that you can get this graph. Okay? So you can show this graph. So I can see directly, okay, then your algorithm. So now you are doing the analysis between DFS and PFS. And we can see from this graph that the time performance is increasing with a linear scheme. When the number of data increase, the time also increase. Okay.